A 4-story wall of water that only rises once in 1,300 years was recorded off the west coast of Canada. Some people blame waves like this for disappearances in the Bermuda Triangle. Rogue waves can get strong enough to sink container ships and oil rigs. The Canadian water monster didn't hurt anyone, but it did become a sensation. And it looks like we're about to see even higher and more powerful rogue waves in the future. The team of Marine Labs, the company that operates the buoy that got caught in the Ucluelet wave, couldn't believe the data they saw. A huge force came out of the blue, pulled the buoy down, and then set it up to a peak before taking it even deeper. They thought it must be a rogue wave, so they sent the data to a scientist at the University of Victoria who specializes in these beauties. They analyzed the data and confirmed it was indeed not a technical mistake. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Scientists have reported seeing giant waves coming out of the blue for centuries, but no one really believed them. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Asteroids. They got in a terrible storm and saw several waves over 98 feet tall. It's almost as tall as a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and shared what they saw. But back then, scientists were sure waves couldn't be taller than 30 feet. Everyone took their story as a tall tale. Unintentional. Over a century later, a cargo ship, the MS München, mysteriously disappeared. People believed it to be unsinkable, just like the Titanic, so it was a real shock that all that was left of it was one lifeboat. When experts analyzed the damage, they concluded that it must have been hit by a wave that was around 65 feet high. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This monster on the North Sea that was 84 feet tall hit the Norwegian gas platform Doppler on New Year's Day. It was twice larger than the wave surrounding it. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. The wave wasn't like any other type of wave they'd studied before. So they had to admit rogue waves were real and gave them an official definition. It's a wave more than twice as tall as others around it. It can pop up lightning fast in a stormy sea, or show up out of nowhere in calm waters. These waves have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters trying to do their job. In 2007, America's National Oceanic and Atmospheric Administration made a list of 50 historical maritime tragedies that were most likely caused by rogue waves. Some of the events on the list happen not in the open water, but in lakes. Lake Superior has something that's got the name Three Sisters. It is a series of 3 large waves, one after another. The second wave covers the ship's decks before the first one is gone. The third wave jumps in and adds extra water. These 3 sisters overload the ship. There's a theory that this phenomenon took down the freighter Edmund Fitzgerald in 1975. There are 2 main theories trying to explain how rogue waves happen. First, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. When these waves cross paths, they team up and become stronger to turn into a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they exchange some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and put in a math model that would create a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but there is a huge progress in this direction. Scientists from the University of Melbourne went on an expedition to Antarctica and found out that strong winds play a big role in the creation of rogue waves. It looks like they're caused by a mix of strong winds and the random way waves move and interact with each other. This idea was tested in labs before, but now they've proven it happens in real oceans too. To study these waves, the scientists use special 3D cameras. These cameras work like human eyes, taking lots of images in a row to create a detailed 3D picture of the ocean surface. It showed that rogue waves happen more often when waves are young, which means they're just starting to form and are more affected by the wind. When strong winds blow over young waves, they make the waves taller, longer, and faster, but not evenly. Some waves steal energy from nearby waves and grow much bigger, which is how rogue waves form. The scientists noticed these giant waves happened about once every 6 hours. They recorded no rogue waves in calmer seas, when the wind doesn't have as much influence. Scientists are concerned that rogue waves may happen more often in the future because there's more energy in the atmosphere and ocean. It looks like rogue waves can be much more powerful than scientists ever thought. They managed to create the famous Doppler wave in a lab for the first time in 2018. This helped them study these mysterious waves up close and showed that their secret is in how they form. We think of waves rolling gently on a beach, but the waves in this study happen in open water when waves from different directions meet. When waves come together from far apart directions, they push the water upward, creating what's called a partially standing wave or a cross wave. This can happen when two seas meet, or when wind directions suddenly change, like during a hurricane. The study found that the bigger the angle between the meeting waves, the taller the cross wave becomes. Normally, when a wave breaks, it forms a white foamy top, and that's where it stops growing. But if a wave is formed by water coming from many directions, it can keep growing even after breaking. These special waves can grow to be twice as steep while breaking, which is already much bigger than normal waves. And if you add up all the growth from waves coming together, they can become 4 times steeper than what anyone thought was possible. This discovery could change the way we build things, like wind turbines or oil platforms in the ocean, to make them safe. Right now, many designs don't fully account for these huge multi-directional waves. Now, they seem to have a lot of similarities, but rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves.
Back in the day, from 774 to 775, Earth got hit with a mega blast of radiation. This crazy burst of energy left its mark. 3 rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast. But astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. After looking at the radioactive carbon and beryllium in tree rings, scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plait thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants. Sorry. Later on, they found this huge hole that was like 23 feet wide and nearly 65 feet deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, these eerie craters have been showing up in specific spots in Siberia where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? All right, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon. Summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show. A bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech. Because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington event. It may not sound like a big deal to you, but it had pretty rough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 1,800 miles per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now, listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms, like the Carrington event, and take notice. Imagine if a similar storm hit today. An internet apocalypse, anyone? Businesses would be sent offline and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit?
Living on our beautiful planet might seem safe, but only until you start thinking of all those dangers lurking just around the corner, or in the vast darkness of the cosmos. Let's see what may eventually lead to the end of planet Earth. With each new potential threat, it gets more and more terrifying. Consider yourself warned. First of all, let's talk about hypercane. This natural disaster can get really extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or a massive volcanic eruption could trigger it. In any case, these conditions would create a hurricane, which, unlike regular hurricanes, would stretch way beyond the lower stratosphere. The speed of such a storm would reach 500 miles per hour. The pressure inside the hypercane would be so low that it wouldn't let it wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It would likely damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Then we've got super destructive tornadoes. A tornado is a violently rotating column of air. It usually extends from a thunderstorm and is in contact with the ground. Inside a thundercloud, warm, humid air rises upward, and cool air falls down along with rain or hail. Such conditions can lead to the appearance of spinning air currents inside the cloud. Interestingly, these air currents start out horizontal, but at one point they can become vertical and drop down from the cloud, becoming a tornado. Some tornadoes are narrow, rope-like swirls, but others turn into wild funnels. Tornadoes are ranked with the help of the enhanced Fujita scale. A weak tornado normally lasts for a few minutes and doesn't move faster than 100 miles per hour. The next level is a strong tornado. Such whirlwinds can last for 20 minutes or so and have winds of up to 200 miles per hour. And then we can also have violent tornadoes. Those can last for more than an hour and move at a speed of between 200 and 300 miles per hour. On average, around 1,000 tornadoes occur in the USA every year. There's even a region that got named Tornado Alley. It's a 10-state area in the Midwest, but tornadoes can happen in any state. One of the most destructive natural disasters was the tri-state tornado in the USA. It was the world's longest-lasting single tornado that traveled 220 miles through Missouri, Illinois, and Indiana. At the same time, the average tornado's path is usually no longer than 5 miles. But what if one day, a tornado much bigger and way more powerful than any we've experienced before swiped through countries and continents? It would leave behind total destruction and devastation. And how about a supercell thunderstorm? It's the least common type of thunderstorm, but it's the most dangerous. It's likely to cause severe weather, damaging winds, very large hail, and even violent tornadoes. What makes supercells unique is a deep and persistent rotating updraft called a mesocyclone. Supercells can potentially last for hours and cause great havoc. An asteroid impact could end all forms of life on Earth too. If a space wanderer was large enough, it could cause widespread devastation, like it happened with the 9-mile-wide asteroid from 66 million years ago. It's rumored to have destroyed 3/4 of the planet's plant and animal species, including dinosaurs. Depending on the asteroid's size and the speed of its approach, the impact could lead to massive fires, tsunamis, and the eternal winter effect. It happens when the debris ejected into the atmosphere blocks sunlight and disrupts the global climate. Luckily, we'd probably notice such a large asteroid coming close to our planet with the help of our equipment long before the collision and would have enough time to get rid of this threat. It would be our very own sun that would bring our world to an end. Our star is a gigantic, constantly changing ball of molten gases. Every once in a while, it spews out bursts of energy, solar flares. They often go hand in hand with something called coronal mass ejections. Those are giant bubbles of ionized gas that can accelerate to incredible speeds. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares people should worry about. They cause the strongest and longest-lasting solar storms. Now, if you had gamma-ray vision, you'd be able to see immensely bright flashes. They occur every day, outshine everything around you, and then disappear again. Those flashes are gamma-ray bursts. One of them could wipe out Earth's atmosphere. The flash that might ruin our planet would most probably be born in a faraway galaxy during a merge of two collapsing stars. It would be immensely powerful and super bright. Still 1,000 light-years from Earth, it'd already shine as bright as the sun. Our planet's atmosphere would try to protect us, but its natural shield wouldn't last. The radiation would be so powerful that it would literally cook the atmosphere. It would create nitrogen oxides that would destroy the ozone layer. Without this layer, ultraviolet rays coming from the sun would be hitting Earth's surface at full force. They would wipe out tiny plankton in the ocean. But these plankton produce from 50 to 70% of all oxygen in the world. So, with their disappearance, there would be a severe lack of oxygen, which would lead to the disappearance of life on the planet. In the end, the heat and ultraviolet light coming from the sun would turn the planet into a huge chunk of rock. And what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest to us black hole is 1,500 light-years away. It seems that we have nothing to worry about until we learn about wandering black holes. Now, things definitely get way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2020, 13 wandering black holes were spotted not so far away from our planet. But not far away in space terms means around 1 billion light-years away, so we've got some time left. Plus, the possibility of such a disaster is very, very low. One day, a rogue planet might push Earth out of the habitable zone and into an extreme orbit farther from the sun. Then, the climate all over the planet would start getting colder and colder. Don't forget that the farther our planet is from the sun, the weaker the star's gravitational pull on our planet is. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Or the sun might expand and turn into a red giant. If it happened, it would change the entire habitable zone of our solar system. The disaster would start with our star running out of hydrogen in its core. This would trigger a chain of reactions, which would eventually lead to the core of the Sun heating up and getting denser. As a result, the Sun would get way larger than it is now. During this transformation, the Sun would swallow Venus, Mercury, and Earth.
Floods, tornadoes, tsunamis, hurricanes, yikes. All these natural disasters can get extremely dangerous, but we're kind of familiar with them. But how about a natural disaster that has never happened before, but could occur any moment now? It might be a super eruption. That's what happens when a supervolcano erupts. You might know that Yellowstone Park is located on top of a supervolcano. The last massive eruption there happened about 664,000 years ago, and the one before that, approximately 1.3 million years ago. If we do the math, we'll understand that the next eruption might be due anytime soon. There's no strong evidence that the supervolcano is waking up or preparing for an eruption, but what would it be like if it did happen? Months before the eruption, small-scale earthquakes would become more frequent and more powerful in the area. Not long before the eruption, the growing pressure would push up the ground over the volcano, creating a dome. Narrow cracks would open along the edges of this dome. The magma would then start rising toward the surface, and then the eruption would kick off. A massive column of lava and ash would shoot up into the air to a height of over 16 miles. The volcano would keep pumping ash for days on end. The air in that area would heat up to 570 degrees Fahrenheit. For all living creatures, ash fallout would be one of the most dangerous consequences of the eruption. Buildings and trees would start collapsing under the weight of this dense substance. It would only take a couple of days for a 10-foot layer of ash to cover the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. The eruption would also be rich in sulfur, and this element is an effective sun blocker. That's why it would soon get so cold that there would be no summer in the whole world for the next several years. The monsoon seasons would change. It would be hard for animals to find food and clean water. Well now, how about a gamma ray burst? You don't stumble across this kind of radiation in your everyday life. A gamma ray burst occurs when two neutron stars collide. The collapse of a massive star can produce it too. Gamma rays could present a serious danger to Earth. If a gamma ray burst happened close to our home planet, it could rip our ozone layer away. After that, we would be left unprotected from the sun's ultraviolet radiation. Plus, gamma rays could also produce ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life. Plants wouldn't survive this disaster either. Now, come to think of it, giant sinkholes could swallow entire communities. One of such sinkholes opened up in the city of New York. It pulled a parked van into the earth. That happened in the summer of 2022. And it wasn't the only sinkhole to appear in that area. Local inhabitants reported about 4,000 sinkholes all over the city. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world, which makes them a global problem. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some areas, there are vast areas of groundwater. But during droughts, this water dries up. This creates large empty caverns, and after heavy rains, the surface over such a cavern can collapse, creating a sinkhole within minutes. Now, what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest one to us is 1,500 light-years away. Nothing to worry about, right? Until you find out about wandering black holes. Now, things get definitely way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2012, 13 wandering black holes were spotted not so far away from our planet. But worry not. Not far away, in space terms, means around 1 billion light-years away. So we've got some time left. Plus, the possibility of such a disaster is very, very low. Another natural disaster we haven't experienced yet is a mega flood. It's never happened before, but the changes in climate do make for a risky potential. It could start, let's say, in California. This state experienced some really bad flooding in the past. One of such floods stretched up to 60 miles across and 300 miles long. If a similar disaster happened these days, it would cause $1 trillion worth of damage. It would also uproot millions of people. Now let's talk about a hypercane. Judging from the name, this natural disaster might get extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or because of a massive volcanic eruption. In any case, these conditions could create a hurricane that would stretch way beyond the lower stratosphere. And as you may guess, regular hurricanes don't do that. The hypercane speed would reach 500 miles per hour. The pressure inside would be low enough not to let the hypercane to wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It could damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Now, this disaster did happen before. About 66 million years ago. I bet you know what I'm hinting at. Yep, that very meteor that supposedly wiped out dinosaurs off the face of the Earth. This 7-mile-wide space visitor was traveling at 67,000 miles per hour. As a result of the collision, 75% of all life on the planet disappeared, and winter reigned on Earth for 18 months. Want to know a secret? Meteors strike Earth all the time. Even more of them barely miss our planet. But it's also very hard to predict meteor strikes. Scientists miss a lot of them until they just nearly miss us. That's why experts are working on an early warning system that could prevent disasters. It could make meteor impacts less catastrophic, or at least allow people time to evacuate. It could also be our very own sun that would be responsible for another natural disaster. I'm talking about a massive solar flare. On the scale of damage to society, few catastrophes can compare to this event. It wouldn't destroy buildings like a tsunami or an earthquake. Neither would it end lives in the same way a supervolcano or meteor would. But it would cripple our entire way of life by destroying the whole electronic infrastructure of Earth. The cost of this disaster would reach trillions of dollars. It'd cause other infrastructures to fail. Communication, medicine, transportation, banking systems, those would tumble like dominoes, and it would be incredibly hard to recover them. Earth would be left without electricity for years. There would be no electric light, no computers, no phones. Water supply systems would be out of order. There would be no food in supermarkets. There would be no electricity, and people wouldn't be able to reboot the already broken power grids. In 1859, people all over the world woke up in the middle of the night. It was as light as during the day. The skies were illuminated with auroras, red, green, purple. They appeared even in the regions where no one had seen them before, like the Bahamas, Jamaica, or Hawaii. Telegraphs got electrically charged, even though they were disconnected. In many areas, fires started. That was when technology barely existed. But imagine the avalanche of problems a solar flare could cause today.
Salt makes our chips and popcorn taste yummy, but it turns out that's not all. It's used in household and industrial products, from cosmetics to fertilizers, from water treatment to road gridding. All over the globe, around 300 tons of salt are produced every year. But there's a problem. That's too much salt for our planet. You see, salt rises to Earth's surface from deep oceanic rocks gradually, and this process is quite balanced, or it used to be. Humans are pushing this balance out of whack. Our demand keeps increasing, and we're releasing too much salt into the soil, air, and sea. And if this process continues unchecked, we might face an existential threat. Yep, it's as serious as that, and a recent study conducted by the University of Maryland confirms this. There is this thing called the natural salt cycle. It's existed for thousands of years. Salt naturally rises to our planet's surface via geologic uplift and rock weathering. Sometime later, rocks break down and release salt ions into the soil. Some of these ions are absorbed by plants and organisms. Others are washed away into rivers, which transport them into oceans. Salt also gets into the atmosphere. It happens through salt dust in dry regions and sea spray in coastal areas. It's crucial for humans because our bodies need salt, just like animals and plants do. Simply put, we're electrical systems controlled by salt. Soil needs salt because otherwise it won't clump together. Plants also need small amounts of salt since those allow them to have proper metabolism and synthesize enough chlorophyll. At the same time, too much salt isn't a great thing, and nowadays, human activity is messing with the natural salt cycle, bringing salt to the planet's surface much more quickly than before. That's the conclusion researchers made after combining data from different sources, including the U.S. Geological Survey's Mineral Yearbook and global records of river compositions and salinity measurements. The main factor bringing about these changes is salt mining for food and other products. Then there are also acid rains. Those increase the rate of rock weathering. These and other factors speed up the generation of salt at the surface of our planet. At the moment, the concentration of salt in the world is too high. The soil, plants, and animals can't use all of it. Even worse, some essential species can't survive with all this extra salt. Their demise changes biodiversity and can lead to the appearance of invasive species, such as phragmites. Those are tall, reedy plants taking over coastal areas. Then, there's also zooplankton, an important ocean species regulating algae. It's extremely sensitive to salt. If this species starts to decline, it might mess with the world's food webs. Too much salt also turns farmlands into wastelands. Recent reports have shown that around 833 hectares of land are already affected. And that's the area around 4 times the size of India. In some countries, huge areas become infertile because of oversalination. Plus, excess salt is bad for our health. The thing is, all that extra salt gets into groundwater, making it too salty for human consumption. It's particularly bad for people with sodium-restricted diets. And I'm not only talking about table salt or sodium chloride. No, other calcium and magnesium-based salts are seeping out too, usually from the production of fertilizers and building materials. It's like a chemical cocktail of different salts coming from various sources, and scientists don't know yet the effects such a cocktail can have on us humans and our health. So, maybe now you're sitting and thinking, oh, it's time to cut back on my salt intake. Perhaps, but don't cut it all out. In the 1930s, Dr. Robert McCants from Cambridge University's Department of Experimental Medicine found 4 volunteers and asked them to go 10 days completely without salt. First, they had to sweat out the salt that still remained in their bodies, and after that, the scientists literally desalinated everything they were allowed to eat and drink. Soon after, the participants started to experience weird sensations. They realized that they didn't taste much flavor in anything they consumed. It got worse. Fatigue set in, and the volunteers soon got too tired to even eat. They began to show the signs of hyponatremia. It occurs when the concentration of sodium in your blood is dangerously low, and that's when a person's blood cells swell because there's not enough salt in the blood to regulate how much water a cell should and will consume. If this condition is left untreated, it can not only result in seizures, but also have much, much worse consequences. At the end of the trial period, participants got some salty foods, And miraculously, within a few minutes, they could taste again, and their energy seemed to be replenished almost immediately. Honestly, it sounds kinda terrifying. If that's what a mere 10 days without salt are, imagine what catastrophe it would be if salt just ceased to exist. We wouldn't be able to last long, that's for sure. And it would be a never-ending drama, not only for us, but for plants and animals too. They need salt as much as we do. If our oceans suddenly lost all the salt, it would wipe out all underwater algae, cutting photosynthesis on Earth almost in half. Land-based plants would follow suit. So, soon after the disappearance of salt, we'd face a huge issue. Too much carbon dioxide and not nearly enough oxygen. Our climate would start fluctuating between extremely hot and cold temperatures, and hurricanes would become insanely powerful and super destructive. Luckily, we still have salt at our stores, and the natural salt cycle might get more or less stable again. By the way, humanity has known of and appreciated salt for many centuries. For example, it was used as offerings and to preserve mummies in ancient Egypt. It was a valuable commodity traded between the Phoenicians and their Mediterranean empire. In ancient China, people knew of more than 40 types of salt and used it for medicinal purposes. In medieval continental Europe, Venice gained power through its salt monopoly. The production and transportation of salt led to the appearance of new cities and the construction of roads. Salzburg, the city of salt in Austria, is a great example of that. Even these days, salt continues to surprise us. For example, recently, researchers from the University of Miami Rosenstiel School of Marine and Atmospheric Science have discovered rare deep-sea brine pools in the Gulf of Aqaba. That's a northern extension of the Red Sea. Those salty underwater lakes are likely to hold secrets about the way oceans on Earth formed all those millions of years ago. They might also give us some clues to life on other planets. Brine pools are some of the most extreme environments on Earth, and still, despite their ultra-high salinity, somewhat exotic chemistry, and total lack of oxygen, they're teeming with life. Researchers have even found bioactive molecules with potential anti-cancer properties in brine pool microbes in the Red Sea. These super salty zero-oxygen brine pools are located close to the coast and might preserve information on tsunamis, earthquakes, and flash floods that took place in the Gulf of Aqaba thousands of years ago. Salt has even made its way into space. Well, kind of. You see, the moon is like a comet soaring through the cosmos. Our natural satellite is followed by a slender tail consisting of irradiated matter, and our planet passes directly through this tail once a month. Well, according to a study published in the journal JGR Planets, this lunar tail is made of millions of sodium atoms. And as you already know, the chemical formula of salt is sodium chloride. Those atoms get blasted out of the lunar soil by meteor strikes and then pushed thousands of miles downstream by solar radiation. For several days a month, when the new moon is located between Earth and the Sun, the gravity of our planet drags that sodium tail into a long beam, which wraps around our planet's atmosphere. The tail itself is harmless and invisible to the unaided eye, but during those new moon days, high-powered telescopes can detect the faint orange glow of sodium in the sky.
This is John. John seems to attract all kinds of bad weather and natural disasters wherever he goes. See for yourself. One day, John notices his dog is restless. The pooch keeps scratching the entrance door and wandering around the house. He even tries to hide in the corner, howling and barking. When some mugs start to clink in your cupboard, John realizes what it means. The noise is produced by foreshocks, mini earthquakes leading up to the main event. Earthquakes often happen in clusters. After a few weak quakes, a much bigger one is likely to be on the way. Sometime before the disaster strikes, people might notice bizarre blue lights. Some of them seem to be coming out of the ground. Others are hovering in the air. These are earthquake lights. They may appear days or mere seconds before the ground starts shaking. Now, John is walking along the ocean shore. Suddenly, he sees the water retreat from the beach. Really, really fast. Uh-oh. John, run away as quickly as you can and find some high ground. A tsunami is coming. And your life might depend on how fast you react. If John spots a bizarre and unexpected rise in sea level, it can be another sign of an approaching tsunami. This happens in 40% of cases. The incoming water is the first tsunami wave. The second one, way larger, will come in about 10 minutes. John can also notice seawater bubbling, swirling, and creating bizarre patterns. It's another sure sign a tsunami is near. John feels there's something strange about the sun. Through his special super dark sunglasses, he sees that there's some uneven flares around the star's contour. If these bizarre rays are accompanied by auroras all over the world, they're a sign of a solar storm. Such storms are usually caused by disturbances in the sun's magnetic field. In this case, the bursts of gas and radiation on the surface of the sun get so massive and powerful that they can even reach our planet. Luckily, solar storms aren't really dangerous for people, but they can mess with electricity and even cause blackouts. The sky over John's head is darkening and turning ominously green. Something hits him on the forehead. Ouch! He picks up the offending object. It's a hailstone, but it's not that cold outside, and it's not raining. Soon, he hears some noise. It's approaching rapidly and turns into a loud roar. It sounds as if a freight train is moving towards him, but it's not a train. It's a tornado. The funnel isn't visible behind a cloud of debris, but John can't mistake this rotating column of air for anything else. Are you on the road, John? Then get as far away from your car as you can. Fast! Find a ditch, lie down in it, and cover your head. Oh, you're inside? Then get away from the windows and hide underground if possible. And please, John, be very careful if you spot some conically shaped clouds. Those mean severe storms. And if you notice that such a cloud starts spinning around, immediately search for shelter. The cloud is transitioning into a tornado right in front of your eyes. On the bright side, John should only worry about warm conical clouds. Cold ones are totally harmless. The only problem is to figure out the temperature of the cloud he sees. Duh! Ah, look, John just spotted some weirdly shaped trees. They look like the letter J and grow on a slope. It means the ground under John's feet is likely to be unstable. If he keeps wandering around, it can cause a bad landslide. Square waves appear when two different wave patterns crash into each other. This phenomenon does look kinda awesome. No, don't go into the water, John. Keep watching it from the shore. Cross currents in that spot can easily pull even a skilled swimmer under the surface. John keeps walking along the shore. At one point, he sees wild, choppy waves carrying ocean debris and seaweed. This time, he stays out of the water. He knows it can be a sign of a strong rip current. It can carry a swimmer far away into the ocean. How about a walk in the park? John likes this idea. The sun is shining and the sky is so blue and beautiful. Suddenly, he spots a rapidly growing vertical cloud. At first, it looks bright white. But as it approaches, alarmingly fast, it becomes dense and inky. The sky is darkening. It's getting windy. That's when the guy notices that his hair stands on end. It's his cue that he's about to get hit by lightning. At this very moment, positive charges are rising through his body. They're reaching towards the negatively charged part of the storm. If he doesn't react fast, these charges will meet. There's nowhere to hide, so John should crouch down and try to make himself smaller than the objects around him. Oh no, John, don't lie down on the ground. It may be damp and thus a great conductor of electricity. There are other signs that scream danger during a lightning storm. John's palms may begin to sweat. He might hear bizarre crackling and buzzing sounds coming from metal objects nearby. His skin can start tingling. There might be a strange metallic taste in his mouth. Plus, John is likely to smell chlorine. That's how ozone smells. Electrical charges split the molecules of nitrogen and oxygen, which are the main gases making up the atmosphere, into separate atoms. When these atoms come together again, some of them produce molecules made up of 3 oxygen atoms. That's ozone. We can smell it during a thunderstorm because downdrafts bring this gas from high altitudes to your level. Some bugs can feel a storm coming. They get ready for a natural disaster by freezing. So, when John notices that insects around him look drowsy, he knows to get ready. Oh, and bees can predict heavy rainstorms. These critters begin to work much harder the day before it starts raining. While walking next to the river during a period of heavy rains, John hears a roaring sound. He feels paralyzed with fear. It's likely to be a flash flood moving in his direction. Indeed, he soon sees debris coming down with the flow. The water is rapidly changing its color, becoming muddier and darker. Flash floods are very, very dangerous. Take care of your safety immediately, John. Another day, John sees a spectacular wall cloud. It seems to be stretching for up to 5 miles. In the best case scenario, it's just a severe storm coming. But if the wall cloud begins to move in a circle, it's a sure sign of a tornado. John is walking across a snowfield in the mountains, listening to the sounds the ice under his feet makes. The noise is kinda hollow. Quickly check whether there are cracks around your footprints, John. If so, the chances are an avalanche is about to happen. Soon, John sees an avalanche moving in his direction. He does his best to get off the slope. In most cases, he could probably outrun it by heading downhill and then veering sideways, but not this time. He realizes he doesn't have enough time and heads for the nearest tree. If John keeps holding on to it really tightly, the avalanche might not pull him along. But if this doesn't work, he should try to swim up to the snow's surface while the avalanche is still moving. On a pretty nice summer evening, John notices leaves with soft stems droop all of a sudden. It might be because of an upcoming storm. Right before extreme weather arrives, the air usually becomes more humid. Leaves also get damp and heavy, and the wind easily flips them over. John lives in a pretty old house and is used to having cracks in the interior walls, but one day, he notices that some of them have widened. And look, there are a few new ones. It's an alarm bell. He lives in an area with loads of limestone, so new cracks can mean a sinkhole is about to open next to his house. John is hurrying home, trying not to waste time admiring shelf clouds. They look like something from a sci-fi movie. They form when warm and moist air gets caught in a thunderstorm updraft, and these ominous clouds most often mean a storm is coming. You're dozing off in your window seat on a plane. It's getting dark since it's almost 11 p.m. Suddenly, something wakes you up. You glance out of the window and see a really strange phenomenon. Something that creeps you out. There are bright red, huge flashes illuminating the sky at a distance. They resemble some nightmarish jellyfish. Those are sprites, also called red sprites due to their color. They're also known as cloud-to-space lightning. These varied visual shapes flickering in the night sky are large-scale electric discharges, which is a clever word for a lightning strike. They occur high above thunderstorm clouds at altitudes of 30 to 56 miles. That's why you can see them so well from your plane window. The coolest thing about sprites is that they're positively charged lightning. This is a very rare type that makes up a mere 5% of all lightning strikes. People first spotted this phenomenon in 1886, and it was first photographed in 1989. In 2018, the legendary Niagara Falls, located at the border between New York State and Ontario, Canada, managed to surprise everyone. Tourists who came to admire the roaring waters found the falls frozen. Well, the waterfalls weren't frozen per se. This is impossible for a mass of flowing water that huge, but microscopic water droplets, as well as the mist, formed a crust of ice over the rushing water. It created an illusion that Niagara Falls was frozen all over. In reality, the water kept flowing beneath the ice. Imagine ponds filled with ice-cold water and covered with ice. Easy, huh? And now picture dozens of alligator snouts that are poking out of the ponds, still and frozen in ice. That's what you'd seen if you had visited the swamps of North Carolina at the beginning of 2018. Despite this terrifying picture, the animals were very much alive. That was a very special crocodile way to survive abnormally cold weather. Since their nostrils were above water, the animals could breathe. Meanwhile, their bodies were in a hibernation-like state. It allowed the animals to conserve energy and stay warm. In the winter of 2018, the inhabitants of the Sahara Desert, one of the driest and hottest places on the planet, woke up to discover a thick layer of snow covering the sand. In some places, its depth reached a staggering 15 inches. Meteorologists had an explanation for this exciting phenomenon. They said that cold pools of air combined with the precipitation of the most recent storm resulted in snowfall instead of rain. It happened in June 2009. People in some areas in Japan left their homes after a heavy downpour, only to find fish, frogs, and tadpoles everywhere. Fields, roads, lawns, and house roofs were littered with these creatures. One man even found 13 carp on and around his truck. No one knows for sure where this bizarre rain came from, but the most popular theory is that a powerful water spout picked up the animals. Then it carried them through the upper atmosphere and dropped them on the unsuspecting people below. In Australia, it sometimes rains spiders. That's because these creatures can balloon. It's a highly unusual way of traveling. A spider climbs to the very top of a tall tree or shrub, and then it spins several strands of silk, which then help the spider to be carried away by the wind. It's not easy to spot ballooning spiders, but sometimes when the weather is especially damp and unpleasant, mass ballooning occurs. Millions of spiders set off on a journey to find another place with better conditions. It may look as if it's snowing outside, but no, those are spiders drifting down to the ground. The world's longest lightning storms happen in Venezuela and can last for 9 hours per day. The heart of the storm is over Lake Maracaibo, and the clouds tower way higher than your regular thunderstorm clouds. This natural phenomenon, also known as catatumbo lightning, occurs during 140 to 160 nights a year and can produce up to 28 lightning strikes per minute. You've probably heard how they say that lightning doesn't strike twice in the same place. Well, catatumbo lightning seems not to know about this rule. At least, it doesn't prevent storm clouds from gathering in the very same place year after year. Volcanic tornadoes are possibly one of the most terrifying natural phenomena. When a volcano erupts, it spews red-hot rock and ash high into the atmosphere. And solid lava pieces and hot gases travel down the volcano's slope. When this flow is moving down, some of the trapped gases begin to rise and spin at the same time. They get squeezed by the surrounding air, which makes them spin faster and faster. That's how a volcanic tornado gets born. Luckily, this phenomenon has a very short lifespan. Even though the island of Newfoundland in Canada can't be called the warmest place on Earth, it's still not that cold. But imagine having to shovel snow in front of your house just several days before your summer vacation. Well, that's exactly what happened on the island in June 2018. A cold storm that came from the coast of Newfoundland covered several regions of the islands with a 2-inch layer of snow. On top of that, the temperature broke all the records as well. During a Newfoundland summer, it's about 66 degrees on average, and 90 degrees on a very hot day. But that infamous June impressed people with only 37 degrees Fahrenheit in the morning. Brrr! Morning glory clouds are extremely rare. They look like massive tubes stretching across the sky. They can snake for more than 600 miles, sitting relatively low. Most researchers agree that these clouds appear when an updraft squeezes through the cloud. This creates the signature rolling appearance. The cool air at the back of the cloud makes it sink downward. The best but not the only place to see the morning glory is Australia's Gulf of Carpentaria. If you decide to travel there to see these clouds, choose a period from late September to early November. On March 19, 2018, the inhabitants of Alabama saw huge chunks of ice falling from the sky. It was the infamous hailstorm of Alabama which caused millions of dollars worth of damage. After the hailstorm, the place looked ruined. Broken shop windows, smashed car windshields, broken billboards, and holes in the roofs. But what made researchers really excited was a hailstone found near the town of Cullman, Alabama. This softball-sized monster was more than 5 inches across, setting a new state record. In 2012, the sky over Dorset, England turned first ominously dark, then yellow. After that, blue gelatinous balls started to fall to the ground. A local man was walking to his garage when he spotted something unusually bright among whitish hailstones. When researchers examined this jelly rain, they found out that the balls were made of the substance used in diapers or potting soil. It's used to absorb liquid. It's still unclear whether the balls fell from the sky or maybe the melting ice made a few already existing crystals expand in the blink of an eye. In March 2018, people in northern Nevada could see the rarest and most bizarre cloud ever, a horseshoe cloud. It sure looks bizarre and kinda scary. But meteorologists know that this interestingly shaped vortex happens when a flat cloud travels over a column of warm, rising air. This air creates the shape and adds some spin to the cloud's movements. Such clouds are very fleeting and usually last for only several minutes. Cylindrical snow donuts occur when a wind gust decides to play snowballs. It starts to roll some snow across a snowy area. If it was a real snowball, it would eventually become too heavy for the wind to move. But the center of a snow donut is hollowed out. This happens because its inner layer is too thin and gets blown away when the donut is formed. This makes it lighter than a regular snowball. That's why it also rolls further. Unfortunately, you can't just go and find snow donuts. They're rare because they appear in very precise conditions.
In Russia, on the shores of the Baltic Sea, there's an enigmatic national park. The Dancing Forest is a place that no scientist has managed to explain so far. The pine trees of the forest are all crooked and twisted into loops and spirals. The forest didn't appear until the early 60s, when the pines were planted in order to make the sand dune in that area more stable. One theory is that it's the unstable sand that made the trees twist in such a way. Other theories for the crooked trees are strong winds, or even supernatural powers. Some people say the forest is a place where positive and negative energies meet, twisting the trees. Local legend says that if a person climbs through one of the rings of a tree, it'll add an extra year to this person's life, or they'll be granted a wish. I like that one. Speaking of bizarre trees, and one grows in the region of Piedmont, Italy. There, a cherry tree grows on the top of a mulberry tree. The strange thing is that both trees are perfectly healthy. A continuous storm at Saturn's North Pole has an odd shape, a hexagon. This is probably because of the gradient of the winds. The total length of this cloud pattern is 9,000 miles, which is about 1,200 miles longer than the Earth's diameter. The hexagon has been observed for many years, but it gets even more mysterious because it changes color too. It used to be turquoise, but it has recently shifted to a golden color. The reason for the color change is that the pole gets exposed to sunlight as the seasons change. Now, rain isn't unusual for Oakville, Washington. However, this one still doesn't have any solid scientific explanation. Instead of common raindrops, people watch translucent jelly-like blobs fall from the skies. These blobs covered about 20 square miles. Those who got really close to the rain experienced flu-like symptoms. What were the blobs? Researchers claim that the blobs contain human white blood cells. Later tests showed no presence of nuclei. Some people claim the blobs might have been evaporated jellyfish resulting in rain, or maybe even waste from a commercial plane. Walking rocks, also known as sailing rocks, move across the Death Valley National Park in California without any external intervention, leaving long trails in the dirt and sand along their way. Various time-lapse footages of the moving rocks have been taken. Scientists even installed GPS navigators on some of the rocks, and it showed that the rocks move at a considerable speed. Some researchers believe that the movement is due to thin sheets of ice that form overnight at freezing temperatures in the valley, letting the rocks move until it melts during the day. Or there was a Rolling Stones concert. Nah. The Batagayka crater in Siberia looks like a doorway to the underworld. It's about a half-mile long and over 280 feet deep, but it never stops growing. As it gets deeper, it exposes more underground layers. The layers show what our planet looked like thousands of years ago, as the slumps reveal the used-to-be climates. The crater appeared back in the 60s, and it all started with rapid deforestation. Trees no longer cast shade on the ground, and it got hotter. The permafrost melted, resulting in the crater formation. The throbbing hum in Taos, New Mexico has driven locals wild since the 1990s. The low-frequency hum deprives people of sleep and depletes their energy. Even though scientists have tried to find the source of the hum, they still haven't pinpointed its origin. Different variations of the hum have also been heard in the UK, Australia, Canada, and other areas of the US. Luckily, only about 2% of the world's population can hear it. The hums have been blamed on mechanical devices, multiple disturbances of auditory systems, and even animals. The West Seattle hum, for example, was blamed on toadfish. Fairy rings, also known as elf rings or pixie rings, are mysterious rings of mushrooms that appear in grasslands and forested areas. There's a lot of debate about why these fungi form a nearly perfect circle. Some superstitions claim that fairy dances would burn the ground, causing mushrooms to rapidly grow. In Costa Rica, there's an assortment of about 300 spherical stone balls. Locals call them las bolas, which is simply the balls in English. These stones have an almost perfect round shape. Some of them are huge, weighing up to 16 tons each. They're also made of different materials: gabbro, limestone, and sandstone. They're considered to have been put in straight lines in front of the chief's houses, but there's no precise information of their origin. Some myths claim that these stones originated in Atlantis. If you ever travel to the Mekong River in late October, you have a chance of seeing glowing balls rising from the water and beelining up into the air. Locals call these glowing balls the Naga fireballs. The size of the lights vary. The reddish balls can be as tiny as a spark and as large as a basketball. There can be dozens to thousands of balls a night. Scientists don't have any solid explanation for why it happens, but it could be due to flammable gases released by the marshy environment. Some superstitious locals are sure it's all because of a giant serpent living in the Mekong. Great balls of fire! In Minnesota, on the north shore of Lake Superior, there's a park known for the Devil's Kettle. This is a waterfall that splits in two. One part of the river continues, while the other part disappears into a hole in the ground. Whatever object you throw into the Devil's Kettle won't reappear. Scientists still haven't fully explained where the water that drops into the hole goes. Devil's Kettle is considered to be unsafe for people because it's nearly impossible to trace the flow. Yeah, not a place to go tubing. Grunions are fish known for their bizarre mating ritual. The females climb out of the water and onto the shore. They dig their tails into the sand in order to lay eggs. The legs stay hidden in the sand, waiting. 10 days later, the high tide comes, washing the newly hatched young to the sea. Scientists still can't give any solid explanation for this way of breeding. People who live in rural central Norway over the Hessdalen Valley can often witness floating lights of white, yellow, and red cross the sky. The lights appear both at day and night, and once back in the 80s, they were spotted 15 to 20 times in a single week. The Hessdalen lights can last just a few seconds, but sometimes they can last more than an hour. The lights move, seeming to float or even sway around. Some scientists believe that the reason for these lights is due to ionized iron dust. Others say it's combustion that includes sodium, oxygen, and hydrogen. Many people claim they're just misidentified aircrafts. Yellowstone Park has a famous boiling lake, but it's not the world's only place of boiling water. Deep in the Amazon, there's the 4-mile Shanay Timpishka River that's always hot. The name means boiled by the sun. Well, it's not exactly boiling, but it can reach 196 degrees Fahrenheit, enough to cook pasta. Ooh, let's try that. The lowest temperature in these waters is about 113 degrees. This river still can't be scientifically explained because it would require close proximity to a volcano for the water to reach such temperatures. However, the closest volcano is 400 miles away. But there could be a fault between the Earth that could explain this phenomenon. In western Venezuela, locals living close to the Catatumbo River aren't afraid of lightning because they see it almost every single night. It starts at around 7 o'clock and doesn't stop until dawn. The everlasting Catatumbo lightning did once stop for a few months, from January to March 2010. It was probably due to drought, or maybe the charge ran out. In 1991, a scientist suggested that the phenomenon happens because of cold and warm air currents meeting in the area. Another theory is that the lightning could be due to the presence of uranium in the bedrock. Speaking of lightning, I got a bolt. Bye! The Boxing Day Tsunami, Indonesia. An undersea earthquake starts in the morning. Its tremors cause a series of tsunami waves. The largest reaches the height of the Arc de Triomphe in Paris. Unzen volcano mega tsunami. A powerful volcanic eruption triggers a landslide from a 4,000-year-old lava dome. It sweeps through the city of Shimabara and reaches the sea, setting off a mega tsunami. The Vajont Dam mega tsunami, Italy. A landslide drags 9 billion cubic feet of forest, soil, and rock into the lake. A dark wall of water covers the sky over a tiny village at the bottom of the Vajont Dam. Then, with a deafening roar, the wave overtops the edge of the dam, taking out everything in its path. Mount St. Helens mega tsunami, USA. As the volcano erupts, the upper 1,500 feet of Mount St. Helens collapses into a massive landslide. Part of this avalanche plunges down into nearby Spirit Lake, which splashes the lake waters into a series of waves almost as tall as the Eiffel Tower. Alaska's Lituya Bay tsunami. A landslide caused by an earthquake creates a mega wave. It surges over the headland and washes away trees, plants, and soil down to bedrock. Molokai, Hawaii. A third of the East Molokai volcano caves in and collapses into the Pacific Ocean. This causes a tsunami the size of the second tallest building in the world, Shanghai Tower. The waves reach Mexico and California. The Yucatan asteroid tsunami. The asteroid, which is rumored to have wiped out dinosaurs, strikes the Yucatan Peninsula. It creates a mega tsunami, the largest in Earth's history. The first wave's almost twice bigger than the world's tallest building, the Burj Khalifa. Hurricane Mitch. Mitch forms in the western Caribbean Sea. Soon it strengthens to become the 8th most powerful Atlantic hurricane ever. The storm pours 4 inches of rain per hour for 2 days in Honduras. It causes terrible mudslides and floods. Hurricane Allen. Rare and extremely powerful, the storm is one of the few to reach Category 5, the highest possible. It causes more than $2 billion in damage. The Great Hurricane. After tearing down Barbados, the storm moves on. It strips the bark off the trees growing on Martinique and St. Lucia and travels further. This horrific natural disaster lasts for 6 days. Hurricane Dorian. It's the most powerful tropical cyclone to hit the Bahamas. The hurricane flattens most of the structures on the islands and sweeps them into the sea. Hurricane Wilma. The storm occurs in the Caribbean Sea near Jamaica and heads to the west. 2 days later, it gathers enough power to turn into the most intense hurricane ever recorded in the Atlantic Ocean. Hurricane Patricia. A regular storm develops a well-defined eye and turns into a Category 5 hurricane within a mere 24 hours. At one point, it travels faster than a Ferrari moving at its top speed. It makes Patricia the world's most intense tropical cyclone ever recorded. Kamchatka earthquake. It happens in the early morning 80 miles away from the shores of Kamchatka. The earth tremors produce a tsunami. The first 2 waves are catastrophic, up to 60 feet high. The third one's much weaker. Valparaiso earthquake, Chile. It happens at about 5 a.m. along the boundary of 2 tectonic plates. The tsunami, triggered by the earthquake, wipes out 620 miles of Chile's coastline. Tohoku earthquake, Japan. The first earth tremors start at a great underwater depth. The earthquake is so strong it moves Japan's main island. It shifts the planet on its axis by up to 10 inches and increases its rotation speed. The disaster also triggers a tsunami with 133-foot high waves that travel 6 miles inland. Indian Ocean earthquake, Sumatra. A rupture along 2 tectonic plates sets off an undersea earthquake. It begins at about 8 a.m. near northern Sumatra, Indonesia. It makes the planet vibrate nearly a half inch and sets off earthquakes all over the world up to Alaska. Good Friday earthquake, Alaska. The most powerful earthquake recorded in North America lasts for 4 minutes and 38 seconds. A 600-mile-long crack causes terrible landslides and a 27-foot tsunami. Areas 200 miles away get raised by 30 feet. Other places permanently drop 8 feet. Valdivia, Chile. The Great Chilean Earthquake starts in the afternoon and lasts for no less than 10 minutes. The disaster affects an area the size of California. It triggers tsunamis that reach the shore of Hawaii, Japan, the Philippines, Australia, and New Zealand. The average tornado usually lasts less than 10 minutes, but there are exceptions. El Reno tornado. It's considered the world's largest tornado based on width. At its peak, the twister reaches 2.5 miles across. The Perryville tornado, U.S. It occurs at about 2 a.m. and starts with snapping hardwood trees and breaking down stone constructions. Then the whirlwind becomes stronger. It levels 2-story buildings, flips and tosses cars as if they were toys. Bridge Creek Moore tornado. When the twister gets into the town of Bridge Creek, its width is at its peak, 1 to 1.5 miles. The wind speed of the tornado reaches more than 300 miles per hour. This natural disaster causes $1 billion in damage. Manitoba, Canada. An outstanding tornado rages for nearly 3 hours. It breaks tons of trees and utility poles, damages roads and farmhouses, but miraculously misses every town on its path. Tri-state tornado, U.S. The world's longest-lasting single tornado travels 220 miles through Missouri, Illinois, and Indiana. The average tornado's path is usually no longer than 5 miles. Tupelo, Gainesville, U.S. An outbreak that consists of at least 12 single tornadoes wipes out everything on its way. The accompanying rainstorms also trigger severe flash floods that make matters even worse. Valjean landslide, Italy. At 10 p.m., a landslide with a volume of 100 Great Pyramids of Giza breaks off from the top of Monte Toc. It falls into the Valjean Dam Reservoir, producing a tsunami wave taller than the Golden Gate Bridge. Yunnan, China. An avalanche of rocks, stones, and mud, so big it could fill up Sydney Harbor, forms a dam on the Jinsha River. The Hida River, Japan. Triggered by a rainstorm, 300,000 Olympic swimming pools of debris flows down before getting stopped by another, earlier landslide. Along the way, the landslide sweeps 2 buses off the road. Peru. A rock slide dams the Rio Montanero, a long river running through the center of Peru. The whole process takes no more than 3 minutes, which means the landslide moves at a speed of up to 87 miles per hour. It also leaves a trail of debris 5 miles long. The Usoy Dam, Tajikistan. Set off by a magnitude 7.4 earthquake, the rockslide falls into the Murghab River and blocks its flow. That's how the Usoy Dam, one of the tallest in the world, appears. Mount St. Helens, USA. At 8:30 a.m., after much buildup, a volcanic vent finally gives way and sets off a catastrophic eruption, which makes the entire north side of Mount St. Helens fall away. It's the world's largest recorded landslide. North Bonneville, U.S. In the middle of the 15th century, a great earthquake occurs. An incredible amount of debris rushes down from Table Mountain. It covers more than 5 square miles and blocks the Columbia River with a dam 200 feet high and 3.5 miles long.